So I want to take a moment to be sure we understand what a redshift is. Because redshift is what shows us that our universe is expanding. It's a visual way that we can see it. So you learned in the previous slide that our eyes operate in the visual scale. Right? We can see colors. And colors are just wavelengths. That's all they are. And we can order our wavelengths from long wavelengths to short. Now, when I say long, I'm talking about the actual wavelength itself. So we're talking about the distance here, right? Amplitude. Okay. So on our long scale, is the color red. Okay, then we have orange, then we have yellow, and we have green, and we have blue, and indigo, and violet. Violet is the shortest. So the way this works, right, the way color works, so let me put up a color here. So the reason why you are seeing me draw this red squiggle mark, or at least red, let's say this was a red piece of clothing, the reason why you see that red is that object is absorbing all the other wavelengths except for the wavelength of red. That's what's bouncing off the fabric or bouncing off the wall. And that's what your eyes pick up. So that's the way colors work, right? By the bouncing of a specific wavelength, that's the color that you're going to see. That's the way our eyes pick it up. So the way redshift works is very similar to something we call the Doppler effect. And I guarantee you've all experienced the Doppler effect before. So let's say, right, here you are sitting in traffic. Right, so you're sitting in traffic. I can't draw, so you're going to have to work with me on this. Right, you're sitting in traffic, right, hanging out. And all of a sudden, an ambulance comes by. So here you have this ambulance, right, that's approaching you, right, with its red and blue flashy lights, and it's making a sound. Well, what happens if you're sitting here in the car is that sound wave is traveling towards you, but it's getting compressed. The closer that car comes, the more compressed that wavelength gets. So what happens is the sound, as the ambulance gets closer to you, sounds higher pitched. Now, as that ambulance moves away from you, that wavelength is now getting stretched out instead. So the pitch sounds lower. I guarantee you've all heard that before at some point in time, either with an ambulance or maybe with somebody rolling down the street playing some loud music. You've heard it before. Redshift works in the same way. So let's say here we are, right? We're standing on the planet. And if I have something, an object, and let's say it's a comet, right? And that comet is moving towards me, well, that means the visual light, just like that ambulance, is getting compressed against my eye. So the closer it gets, right, the more compressed that wavelength gets. So since it gets compressed, the light is going to shift to the blue scale. We call that a blue shift. So what that means, right, let's lay out our colors up here. Remember we had Roy G. Biv. Right, here's the short, here's the long. So let's say this comet was initially green, right? As it comes towards you, you might see it as blue because that wavelength is getting compressed. So it's shifting to the next color. Now let's say I have a supersonic arm and I can throw a baseball really fast, really far away. All right, so here I got my baseball. I'm throwing it fast. Since it's moving away from me, my wavelengths are going to get longer and longer. So instead of everything shifting towards the short, it's going to shift towards the long. So let's again say here my baseball is green. Well, the further and further it gets away from me, it's going to shift towards the red. And that's what we call redshift. So when we see an object moving away from us, it shifts to the color red or towards that number wavelength. So when we look at all of our galaxies, right, and when we can view them from our telescopes, and we look at them in this visual light scale, what we see is they're all shifted towards the red, telling us that they are all actually, in fact, moving away from where we are. So that's why understanding the visible light scale and understanding redshift and blue shift is extremely important.